All right, so we're going to relate this to sound and musical instruments later on, but just to give you a start on it. Frequency of an oboe's A is 440 hertz. What is the period of this note? What's the relationship between frequency and period? They're inverses of each other. So period is 1 over F. Better color. Doesn't improve things much. So if you know the frequency, you can calculate the period. The period is 1 over 440 hertz. And if somebody would be so kind, all right, we'll leave it in a fraction. 1 over 440 seconds is the period. Now notice, be careful about this, the units of frequency go in the denominator. They're 1 over S. So the units of period is S, but I don't want to put it in the denominator. That's wrong. Just be careful about that as you go through. So what's the wavelength of this? You can either calculate wavelength. If you're given a diagram, you can look for the repeating pattern. Or for wavelength, you can use the speed of sound. E equals F lambda. Speed is 340 meters per second. Frequency, 440 hertz. Times the wavelength. Wavelength is 340 over 440. Better in decimal form? Can you do it yet? 0.773. Units? No. Meters. Units are meters. If you look at the units here, it's meters per second. So we're going to divide by 1 over seconds. All we're left with meters is a unit of wavelength. And when we get to light, then it will be in nanometers. But for sound waves are long waves, meters long, or half meter long. We're going to take a second and look at different wave types. Again, this is terminology, but you have to know the terminology. It's a lot different than what we've done before. A transverse wave is a wave in which the particles of the medium move perpendicular to the wave direction. So the wave direction may be left and right. The particles of the medium would be up and down in that case. What is this? Waves on a string. It's a typical wave pattern. We're going to demonstrate this in a second. Longitudinal wave is a wave that the particles move in the same direction. So this would be a compressed slinky wave or a sound wave. Sound waves move by bouncing this way. They bounce, and it hits the next one, they bounce, they hit the next one, they bounce. So they're bouncing in this direction. The wave is traveling that direction. The particles are bouncing in that direction, so we call it longitudinal. They're going in the same direction. If I were to swing a rope up and down, the rope particles are going upwards and downwards, but the energy of the wave is traveling left and right. So those are perpendicular to each other. That's what we call a transverse wave. And let's take a look at those two types of waves.